Okay, so today what we're going to be learning about is how to use equations to help us solve word problems, okay? We've been working with equations a lot, solving all different types of equations. Today what we're going to be looking at are some problems, and then we're going to be looking at that information and then transferring it into an equation and then setting up an equation to help us solve, okay? So first we're going to write down a few steps, and then after we write down a few steps, we're going to use the yellow note-taking sheet you guys have to work some problems on here. I gave you guys a short note-taking sheet. That way you wouldn't have to copy down the whole entire word problem for every example we did. Okay. So once we're done with this, you're just going to go ahead and you can staple it into your notebook. Does that make sense? Okay. All right. So let's write down a few of the key steps. Okay. One of the things is we want to highlight or underline any important information. Okay, so that's a big thing. So we want to read that problem and look at, okay, what is the important information they're giving me? Then we want to think about, what is the question asking? Okay, so we want to actually identify what is the question. Okay, and then when we answer, we want to think about what units of measurement should the answer be. Okay, so if they're asking us about the number of dogs or the number of shirts or the number of dollars or the number of people, we want to think about, okay, what is the answer going to be in? Am I talking about when I'm answering the question, what kinds of things are they asking me? What do those numbers represent, right? Okay, and then the last is we want to think about, is our answer reasonable, or does it make sense? Okay, so if you get if they're asking you some maybe the question's about how many people will be riding the bus on the field trip, that's the question. They gave you a bunch of information, they're asking about how many people will be riding the bus. And then for your answer, you get 27.8. Can you have 0.8 of a person? Can you have a fractional amount of a person? Is someone going to ride, is half of a person going to come ride the bus? That answer wouldn't make sense, right? Or, I mean, if we literally think about it, if we had 0.8 of a person, that means part of, what? The zombie comes and rides the bus, with their head chopped off or something, that doesn't even make sense, right? I mean, unless we're talking Walking Dead here or something. But, okay, in these problems, right, we need to reflect on what kinds of units are we talking about, and does our answer actually make sense, right? Because if we're talking about our answer should represent a number of people, and then we get 0.8 people, then our answer doesn't really make sense, right? Okay. So let's take a look at some of these questions. Okay, so get out your yellow sheet and we're going to look at some of these questions together. Okay, so in this first question, and if you have a highlighter or a colored pen or something like that, you can get it out right now because that would be helpful. Okay, so let me give you guys a minute to get out something like that. If you don't have a highlighter or a colored pen, you can just underline with your pencil, and that works too. Okay. So let's go ahead and read this first question here. It says an ostrich that is 108 inches tall is 20 inches taller than 4 times the height of a kiwi? Do you guys know what a kiwi is? The fruit or the bird? What are we talking about here? Probably the bird, right? We're comparing it to an ostrich. Okay. So an ostrich that is 108 inches tall is 20 inches taller than 4 times the height of the kiwi. What is the height of the kiwi in inches? Okay, so what I see here is this is the question. This is what they're asking me, right? This is my question right here. What is the height of the kiwi in inches? That's what they want to know. Now, what is some important information that they gave us here? Yeah, the ostrich is 108. Okay. What else did they tell us? Yeah, the ostrich is 20 inches taller than what?
4 times.
Yeah, 4 times the height of the kiwi. Okay. So let's see if we can transfer this information into an equation. Okay. So I know this ostrich is 108 inches tall, right? And it told me that that is basically the same thing as being 20 inches taller than 4 times this kiwi, right? So if this 108 is equaling all this stuff, that's basically what it's saying. This 108 is means equals the same as this, right? So 108 is 20 inches taller than, so if he's 20 inches taller than the kiwi, it's adding 20 inches or subtracting 20 inches from the kiwi's height? Adding, right? 20 inches taller than, so that would be adding. And it's not just taller than the kiwi, it's taller than 4 times the height of the kiwi. So how would I represent that? Do I know the height of the kiwi? No, so that needs to be a variable, right? So I'm going to let this height, this is my unknown information, this is going to be the variable. So what letter do you guys want to use for your variable? H. So 4 times H, so 4H. Does that kind of make sense how we set up that equation? So the ostrich, which was 108, is, which means equals, 20 inches taller, so 20 added to 4 times the height of the kiwi, so 4H. Does that make sense there? Okay, so now the hardest part of these problems today is setting up the equation correctly, okay? But once you have the equation set up, is this a pretty easy equation to solve? Yeah, let's go ahead and solve it, okay? So what will we do first to solve this? Yeah, subtract 20 from both sides. Okay, so what would you guys get for that? 88? Mm-hmm. Okay, and then what would the last thing be? Divide by 4, so what will we get for H?
22.
Yeah. Now, let's look back at the question and see what is the question asking us. The question is asking us what is the height of the kiwi in inches. So let's answer it. The kiwi is 22 inches tall, right? That's my answer. And then let's kind of think about, does this answer make sense? Okay, well, we know the ostrich told us was taller than the kiwi to start with, right? So is 108 bigger than 22 at least? Yeah, okay. And then we knew that it was 20 inches taller than 4 times the height. So if we take this and we do times 4, then we add 20, then yeah, we end up getting 108, right? When we like plug it back in and check, okay? So does this answer make sense? Yeah, okay. We're not getting some crazy number like 2,000 inches or something that doesn't even make sense, right? Okay. All right, so are we okay with that first one? Yeah? Okay. All right, let's take a look at the second one. Okay, so I want you guys to read this one as I read it out loud. Okay, you're just going to read along with me. Jennifer is saving money to buy a bike. The bike costs $245. She has $125 saved, and each week she adds $15 to her savings. There's supposed to be a T here. It didn't get printed. To her savings. How long will it take her to save enough money to buy the bike? Okay, so first of all, what's the question asking? Is it asking how much money, or is it asking amount of time? Time. Okay, so our unit of measurement is, it's asking how long. This is an amount of time, right? Does that make sense? So specifically, okay, what kind of unit of measurement of time did they already give us? Did they tell us days or hours or months or weeks or years? What were they talking about in some of the key information here? Weeks, right? So I'm going to highlight that because I'm thinking my answer, I'm going to be giving my answer in weeks, right? Does that make sense? Okay, now let's look at some important information. We're trying to figure out how long she's going to have to save for the bike. Okay, so how much does the bike cost? Okay, that's $245. So that's the total amount that she's going to have to save, right? Okay, does she have some money already? How much? Okay. And what is she adding to that amount? 15. How often? Every week, right? So each week she's adding $15. Okay, so let's write an equation to help us solve this, okay? So think of one part of your equation, one side is going to be like the total, and the other side is going to be how we're making up the total, okay? So what's the total that she's going to have to save? $245. Now the other side of the equation is going to be how she's getting there. So how much does she already have? $125 plus she's saving more. How much is she saving? $15 every week. So do I know how many weeks she's going to be saving for? No. So this is going to be your variable. Your number of weeks is your variable. So what variable would you guys like to use? W? Okay. So she's saving $15 per week, so 15 times W, right? Like if she only saves 1 week, she's only saving 15. If she saves 2 weeks, then it's 30. And 3 weeks is 45, and so forth, right? That's why we're multiplying by the number of weeks, okay? Because that $15 is increasing every week, right? Okay, so now, is this an equation you guys can solve? Okay, so go ahead, try solving this one. Okay, so what would you guys do first? Yeah, subtract 125. What is that giving us? 120. Okay, and then after that, what would we do? Okay. Did anyone figure out the division yet? What we got? 8? Okay. So let's go ahead and answer the question. They want to know how long is it going to take her to save enough money. It will take Jennifer 8 weeks to save enough money. And then if we want to, we can go back and we can kind of like backwards think this, right? Using the number 8. 8 times 15. Okay, if she saved for 8 weeks at $15 a week, that would be 8 times 15 would be 120. And then we would add that to what she had already had, which was 125, and that should equal the total. So does my answer make sense when I go and backwards think this into the problem? Yeah. Okay, so it's a reasonable answer. Okay? Are there questions on that one? Any questions? Okay. Let's take a look at the last one here. Okay? All right, so I want you guys to read the problem. Follow along with me as I read it out loud. Okay? Chelsea cleans out her closet. She gives half of the t-shirts in her closet to the Goodwill. Then she goes shopping and gets 7 new t-shirts. If she now has a total of 22 t-shirts, how many shirts were originally in her closet? Okay, do you guys see what the question is? What's the question? How many were originally in her closet? How many what? What is it asking me about? How many shirts? Okay, so that's important, right? So my answer is going to be representing a number of shirts, right? Okay, now, what's the important information that they gave us? She started out with some shirts, but then what did she do? She gave half away, okay? So she gives half of them away. And then she went shopping, and how many more does she get? 7. So she gets 7 new ones. And what's her total she ends up with? 22. Okay? So let's try to write an equation. Okay? One side of the equation is going to represent the total. Okay, the other side is going to represent how we're getting there. Okay? So her total was 22. Okay? What's the unknown thing we're talking about? T-shirts, right? So t-shirts is going to be my variable. It's the unknown number. Okay, so what do I want to use to represent my t-shirts? S for shirts. Okay. Okay, so she had some number of shirts to start with. Okay. She gave half of them away. So didn't she take her whole amount, basically cut it in half? If she gives half of it away, doesn't she still have half left? Okay. So she basically took the total amount and divided it by 2. Right? She's giving half away. If she started with 20, how many does she have left? If she started with 50, how many does she have left?
25.
So whatever this number she started with was, we're cutting it in half. We're dividing it by 2. Does that make sense why I wrote it like this? Because if she started with 50 and we divide it by 2, she has 25 left, right? If she started with 100 and divided it by 2, she has 50 left, so forth, right? Okay, now, what did she then buy?
7.
So she's adding that to whatever she had left, right? So we're adding 7. Okay, and this whole thing equals the total that she has. So let's solve that. Okay, so what would you guys do to solve this? You want to multiply all the parts by 2? Times 2, times 2, times 2 to get rid of that denominator. Okay, so what's 2 times 22?
24.
And those 2's cancel, and that makes 14. Okay, so what do you guys want to do next to solve?
Subtract by 2.
Yeah, subtract. Okay, and so what do we get S equals?
30.
Okay. So the question was, how many shirts were originally in her closet? So Chelsea originally had 30 shirts in her closet. Now, let's go back and just rethink this and make sure that answer makes sense. She started with 30. She gave half away. So how many will she have left then? 15. She bought 7 new ones, so it's 15 plus 7, 22. And now she has 22. Does that make sense? Does our answer make sense when we go back and think about it? Yeah. Okay. All right. Are there questions on what you guys are doing today? No. Okay. So your homework for today is the C3 worksheet that is on Google Classroom. You're going to do problems 1 through 12. Okay? There's like a lot of problems on that worksheet. There's like 30 total. It's like multiple pages. You're only going to do numbers 1 through 12. Okay? All right. Are there questions on what you guys are doing? Okay. All right. I want this to get stapled into your notebook. You can either staple it on the front or on the back side of this page. I'm going to pass staplers around so that you guys can do that, okay?